So we've been talking a lot about how to find solutions to these quadratics. We've been showing you many different methods to be able to get to that. What we want to do is we want to look at some of these methods and just some of their advantages and disadvantages. Depending on the quadratic that you have, you'll have several choices to pick from as to which one you want to go about. Some will be easier to use than others. So the first one we talked about was factoring. Factoring is an important one. And when we have an equation that is pretty straightforward, and we can kind of see that it can be factored easily, one of the quickest ways is to use your factoring, because then with the zero product property, we can find our answer or our solutions quickly. The disadvantage is that some equations are not factorable. And if they're not factorable, then we won't be able to use factoring to get the answers or the solutions. And unless you can recognize which ones are or aren't, you could be spending a lot of time trying to factor something that just can't be factored. Then the second one we talked about was graphing. This was our 9.1 section. For our advantages, we can easily see the number of solutions. I mean, obviously we have a visual of a graph on a coordinate plane, and where you see its x-intercepts, those would be our solutions, and you can very easily see how many we have. Okay, we want to use this method when approximate solutions are sufficient. We're not always going to get something that is a nice perfect integer that we can see exactly where it's crossing. But if we're okay with something that's pretty close and we don't need an exact solution, then graphing is good. And then certainly an advantage you can always use is if you have a graphing calculator, then you can get the exact answers with the graphing calculator because it will do the exact work you need. So the disadvantage to the graphing method is that it's not always going to give exact solutions, and you have to be okay with that, or just hope that it lands on a nice perfect integer that you can use that as your answers. The next method we worked on and talked about was 9.2, which was using square roots. And remember, this one was where we tried to use only when we had our ax squared plus bx plus c, where we only had the ax squared with the x variables. If we had the bx in it, then this would not be the method to go. But basically what this one was saying was we use equations when we can get them into this form, x squared equals d, because then when I take the square root, I can get to my answers really quickly. The disadvantages obviously are it should only be used for certain equations, and certainly anything that has ax squared plus c or ax squared. If you have a bx in there someplace, then this is not a method that you can use. The x's in one of the terms only is the only way that this square root method works. Then we talked about completing the square. So completing the square has several steps to it, and it's going to take some practice for some of us to be good at it. But it's best used when our a value is a 1, okay, and the b value is an even number. If you recall the steps, we ended up taking the b value and dividing it by 2 or multiplying by a half, and then squaring it and then adding it to the other part. So obviously an even number is much easier to cut in half and then to square it and then to plug it back in. When we're then creating our perfect square trinomials, a 1 in front of the a value is obviously much easier to work with as well. The disadvantage of the completing the square is that it can be difficult. It's something that you have to get good at, you have to get a good feeling for. There are several steps that go to it that you have to make sure that you understand so that you can make sure that you are accurate with your results. And the calculations can be difficult. And then lastly, we looked at the quadratic formula in the last section. The quadratic formula's advantage is the following. It can be used for all quadratics. Every single quadratic that we have worked on so far, the quadratic formula will find you your answers. The other benefit is that it's going to give us the exact solutions. It's not going to give us approximate answers. We don't have to kind of round and guess things. The quadratic formula, when you run your numbers through, is going to give you the exact solutions. Now, the disadvantage, obviously, is it takes time. It's something that's not an easy formula. You have to think about your PEMDAS, you have to think about your positives and your negatives and your square roots. It's not something that is an easy one to go through. It takes some time. You need to be neat and organized to make sure you get the right answer. But anytime you have a quadratic, you can always use the quadratic formula. So now we want to kind of talk about using some of these different methods just with a few more of our quadratics to see how they work. For example 1, we have a quadratic that was given to us and we're asked to basically solve it using 2 different methods. And again, different people are going to use different ways. There is no potentially right answer here. We should get the same answers whichever method we use. I'm going to go about with this one trying to see if I can factor, because I'm pretty sure I can see right away that I can factor. And then the other way is I'm going to go with graphing. Okay, so for the factoring way, basically what I'm seeing right away is I can, with a 1 in the front of the x squared, that's going to make this a little bit simpler to find my answers. I'm going to set up my double bubble. If I focus on the factors, on the factor pairs of the number 12, that will produce a sum that is an 8, I'm going to see that 2 and 6 will produce that. And remember, when you factor these things, we always can think about a check by just simply using FOIL, and we would see that x times x is x squared, 2x plus 6x is my 8x, and the 2 times the 6 is the 12. At this point, we would then set each of these expressions equal to 0, and we would then solve by isolating the x. So x equals -2 and x equals -6. So the solutions to this quadratic are x equals -2 and x equals -6. That is solving it by the factor method. Now I want to think about the graphing method. So when I think about the graphing, the quadratic that we were given was already in standard form. So with that, I'm going to go through my steps. I'm first going to find my axis of symmetry, and I do that, remember, by finding the x equals -b over 2a. My b value is the 8, so it is -8 over 2 times the 1 for my a value. -8 over 2 is x equals -4. So our axis of symmetry is at -4. So next what I want to do is I want to kind of start setting up my graph. Draw my y-axis. Draw my x-axis. Oh, it's not a really great line there. And I know that my axis of symmetry is at the -4. So our axis of symmetry is sitting right there. That's kind of telling you our line of symmetry is going to give us our mirror image on either side. But next what I need to do is I need to plug my -4 back into our quadratic to find out what is the y that matches with it. That will help us find our vertex. -4 squared is 16, minus 32 plus 12 is -4. So my vertex is at -4, -4. So I can plot that point right there at -4, -4. That is our vertex. From here, what I want to do is probably make a little bit of a table, and if I make my table, I can kind of center it at -4, -4, because everything's going to kind of revolve now around this coordinate right here as our vertex. So if I was to plug in the -5 and the -6 and the -3, I'm going to get some values here. -5 will go in and give me a -3. And if I plug in a -6, I get a 0. And with my ideal, symmetrical laws, I'm going to come to the other side here, and when 3 goes in, sorry, when -3 goes in, I'm going to get -3, and we can then plot some points. So to finish my points here, I'm going to get -5, -3, -3, -3, and then I'm going to get -6, 0, and I would also get negative 2, 0. Then I can kind of draw my curve, and basically what I'm looking for are my two x-intercepts. Those will be my solutions. So the x-intercepts are the solutions. So x equals negative 2, negative 6. And again, we should have gotten the same answer with either method. With the factoring method, we got negative 2, negative 6. And now with the graphing method, we also got negative 2, negative 6. So for the next one on example 2, part A, when I look at this one, I kind of think ahead that I would subtract 1 from both sides to decide if I could factor this. But I have no factor pairs of 1 that are going to give me a negative 10, especially when my A value is a 1. So I know that I can't factor this one. So what I'm going to try on this one is I'm actually going to do the completing the square. Okay, so here's where we want to think, how do I complete the square? And again, remember there were several steps on this one. But completing the square, remember step 1. We want to have the ax squared plus bx on one side. When it's on the one side, what I want to do is I want to take the b value. So step 1 is to take b value and do 1/2 of negative 10, which is our negative 5. Then what we said was in step 2, you take that negative 5 and you square it, which gives us 25. We then add that to both sides. So we initially had x squared minus 10x equals the 1. And now what we just found was we're going to add 25 to both sides. And again, I think the part with the completing the squares, you have to remember adding it to both sides. Well, now on the left-hand side, we have a perfect square trinomial, and that will give us x minus 5 squared equals 1 plus 25 is 26. From here, what we do is we then take the square root of both sides. And by taking the square root of both sides, it kind of frees up the x minus 5 times x minus 5 to give us just x minus 5. And on the other side, you're going to notice that we now have a plus or minus square root of 26. Obviously not a nice perfect square, so we just can't assume that it's always going to be perfect. We'll just have to deal with it the way it is. But what we do next here is we now have taken the x single variable out of the kind of the square there, and now I just have to add the 5 to both sides. 5 to both sides. And see what we have. If I add 5 to both sides, I get x equals, I get the positive square root of 26 plus 5. I also get the negative square root of 26 plus 5. And now again here, I don't expect you to do this one out in your head and try to figure out what is the square root of 26. Square root of 26 we can do on a kind of calculator very simply and then add 5 to it. We can also do the negative square root of 26 and add 5. And our two solutions are going to be about 10.1 and approximately negative 0.1. So here we come to the last example of this section. When I look at this one, I kind of see something that looks a little bit crazy. It doesn't look like nice, easy numbers. I certainly would like to think of factoring right away, but you know what? We've already done graphing, we've already done factoring, we've already done completing the square. So I think I'm just going to jump right into, let's just do the quadratic formula. So we're going to do the quad formula. Again, more for practice than anything else. So remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this one we already have everything on one side in standard form, so all I really have to do is just start kind of plugging in. And again, I have a negative negative 13, which is going to give me a positive 13, plus or minus square root of 13 squared, negative 13 squared minus 4. My a value is a 2, and my c value is a negative 24, all over 2 times my a value, which is a 2. I go a little bit further here, and I now have 13 plus or minus square root of 169 plus 192 divided by 4. X equals 13 plus or minus the square root of 361, all divided by 4. That's going to give me x equals 13 plus or minus 19 over 4, which is going to give me, when I do 13 plus 19, 32 fourths, or 13 minus 19 is negative 6 fourths. So my answers here are 8 or negative 3 halves. So this one actually didn't turn out to be too ugly once I got down to my solutions, which makes me think I probably could have graphed this one and not been too far off, but you don't know that until you actually do it. The other thing that you will notice, and some of you may have seen this already, if you had focused on the factoring, this one is factorable. So certainly if you were somebody that really wants to get it to be factored, this one would have been factorable. You would have come down to 2x plus 3 times x minus 8, which would have given you your same two solutions of 8 or negative 3 halves. So really I think the big thing about this section in between here is just to kind of let you know that all these different methods are there for you to use. Different ones will be more successful than others, and it's kind of up to you to start figuring out which one works best for you.